All right, guys, just a quick video here on the electron configuration. Really, the electron configuration comes from the orbital diagram. So I'm going to kind of bounce back to our previous video where we were talking about carbon, sulfur, and nickel and how we actually write the electron configuration. So the orbital diagram is the drawing of the actual orbitals, the electrons, whether they're spinning up, spinning down, where exactly they are placed for each element. And then the electron configuration is actually the written version of those. So I'm going to kind of have both of them here, hopefully, for us to kind of be able to refer to or reference back to as we're kind of moving on with the difference in the two. So again, with the electron configuration, we just want to kind of note what orbitals are being occupied and how many electrons are being occupied. So again, this is our electron configuration. The orbital diagram is the actual drawing of the boxes and the electrons. The electron configuration for carbon would simply be, what did we fill out? So we have filled out 1s. How many electrons did we put in there? We put an up and a down. So we say 1s2 because we put 2 electrons in there. If we go to our next level, we have 2s, and again we have 1, 2. So we're going to say 2s2. And then we go to our next level, which is p, and now we have 1 up, which is, again, a total of 2. So the configuration, the electron configuration for carbon is simply 1s2, 2s2, 2p2. And that should make sense because if we add the number of electrons that we put in there, it should add back up to our atomic number, or the number of, the number of electrons inside of carbon. All right? Again, so the orbital is important for getting our idea of what spin the electrons have and where exactly they are located. The configuration is really condensing that down to what level, 1s, how many, 2, 2s, 2, 2p, 2. And again, the total number across is going to equal out to our previous number of electrons, or the atomic number of the element. So if we slide this up here, for sulfur, again, we had a total of 16 electrons, but we're going to take a look at what did we fill out. We always start at the lowest level, 1s2, 2s2, 2p. Now this time we did 1, 2, 3, 4, 5, 6. We went up to 3s. Oops, sorry, that's an s. My 2's and s's are starting to look like. We filled out 2 there. Then we're going to go up to 3p, and we have 1, 2, 3, 4 inside of there. And again, getting confused. I apologize. That is a total of 3p4. So our electron configuration for sulfur would be 1s2, 2s2, 2p6, 3s2, 3p4. If we add it up, 2, 4, 10. Oh, there you go. Sorry. 2, 4, 10, 12, and again that's 16, which is the number of electrons that we should have had right there. All right. So it's pretty basic, simple kind of stuff that we're doing. If we wanted to take a look at, we'll take a look at our orbital diagram here for nickel. If we take a look at nickel here, as our orbital diagram shows, we go all the way to 3D, so we want to make sure that we copy all of those levels as we actually get started here. So for nickel, you'll notice the pattern pretty quickly. 1s2, 2s2, 2p6, 3s2, 3p6. Now remember, we get all the way up to 3p, and instead of going to 3D, we fill up 4s, because again, the 4s takes less energy than 3D does to fill out. So there's 4s2. Now we get up to 3d, and we have 1, 2, 3, 4, 5, 6, 7, 8, 3d, 8. And again, if we added them all up, it would get us to the 28 number that we needed for nickel. So all electron configuration is writing out the level and the number of electrons that go in each one of those levels. And so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8, and all of those are just following the chart, alphabetical set for us to understand what's going on. Now there is another step that we are going to throw in here. This is all considered longhand version because we're writing everything out. There is a shorthand version, but it really doesn't pick up until you start getting into the 3p kind of angle, because as you see right here, it's pretty short. Could we write this in what we call shorthand notation? Yes, but it's not really saving us time. Once we get to sulfur, we get to nickel, anything beyond that, now we can actually do what's called shorthand notation. And so the shorthand notation is quite simple in that we go to the last noble gas that was filled out. So if we take a look here, here's sulfur. We're going to go backwards to the last noble gas that was completely filled out, and those are going to be in our P ranges, and it's going to be a P6 of some sort as the last noble gas that was going to get filled out. So for here, we're in this second level. All right, this is the P orbital, so 2p6 was the last full noble gas that was filled out. So in shorthand notation for sulfur, we start by putting a bracket and we put the noble gas inside the bracket. This assumes everything up to the point that noble gas has been filled out correctly. So the 1s, the 2s, the 2p has been filled out correctly. When we are done putting that in the bracket, all we have to do is fill out the remaining information. So 3s2, 3p4. So what it's saving me is doing the 1s2, 2s2, 2p6. By putting neon in a bracket, we assume all of that information. And now we're going to just put what's beyond that noble gas that's been filled out. And again, we know which noble gas has been filled out because it's the last P6. All of our noble gases in our P6 ranges are there. So if we take a look at our other one that we had, that's significantly longer, is going to be nickel. And so for nickel, again, we're going to take a look at what was the last noble gas that we filled out. So here, and if we come back, we go up to the level, we're going to notice that argon at 18 was the last noble gas that was filled out. So all we have to do is simply put our bracket, put AR for argon. We're going to take a look. Here's our last P level that was filled out to 6. All of this information is assumed when we draw the bracket AR. And now all we have to do is 4s2, 3d8. So you can see the shorthand, once we start getting up into those elements, the upper 20s on up, the shorthand really becomes a lot easier than having to write out 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2, 3d8. Now we just have to put argon in a bracket. This is all assumed, 4s2, 3d8. Again, there are two forms, longhand and shorthand. The shorthand really comes into play once we get to those upper 20s, 30s, and beyond elements. Again, if you have any questions, just let me know. But this is just the electron configuration, which comes from the orbital diagrams in the previous video.